equations. So here are our steps to solve. Step 1, locate the variable. Okay, step 2, determine the operation tied to the variable, meaning what operation is being done to the variable that you see. So if we look at number 1, what operation is being done? We're adding. Does everyone see that? Okay, if we look at number 2, what operation are we doing? 3, what are we doing? Adding. We're adding, right? So first step is always to figure out what operation is being done. Then step 3 is to use the inverse operation on both sides of the equal sign to solve the problem, and then you get to check your solution. Guys, remember how we talked about the inverse property? Remember that was one of your properties we talked about, is the inverse property? So if I give you an addition, what is the inverse property of addition, or inverse operation? Subtraction, meaning if you see an addition problem, you are going to subtract because you want to do the opposite. If you see a subtraction problem, you want to add because you want to do the opposite. So essentially, inverse means opposite operation. What is the opposite operation of what you see? You are doing the opposite. So if you see a multiplication problem, what do? What's the inverse? Divide. If we see a division problem, what's the inverse? So multiplication and division are inverse operations. You are doing the inverse operation. All right. So here's kind of how I teach it. When we look at this number 1, okay, I've always taught that you need to draw a line to split up your two sides. Okay, you have two sides of a problem. Your two sides of your problem is split up by your equal sign. Okay, so I always teach that you draw a line down your equal sign so you can see that x plus 7 is on one side and negative 1 is on one side. You have two sides of the equation, and it's just like a fraction. Whatever you do to one side of the equation, you have to do to the other side of the equation. Must be done to both sides. That's what number 3 says in your step-by-step. So your job is to isolate the variable, meaning get the variable all by itself. So I don't want x plus 7, I want just x equals whatever. So I have to figure out the number next to the variable is a 7, and what operation is being done? I need to use my inverse operations that we just talked about. What's the inverse of addition? So I am going to do what then? I'm going to subtract that 7, right? Because what is 7 minus 7? 0. So those 7s go away, and I'm left with just the x. Does that make sense, guys? No. What's 7 minus 7? 0. The 7s went away because it's a 0, right? 0 means it's gone. Yes. Okay, so then whatever you do to one side, you have to do the other side. So if I subtract 7 on one side of that line, I have to subtract 7 on the other side of my line. Because it's just like a fraction. Whatever you do to one side, you have to do to the other side. And then I have negative 1 minus 7. Don't forget your integer rules. What is it? Negative 8. So that means that x is equal to negative 8. Okay, then step 4 is to always check your solution. So if I plug this back in, if x equals negative 8, I say negative 8 plus 7 equals a negative 1. What is negative 8 plus 7? Does negative 1 equal a negative 1? That is how we know our answer is correct. Because the number I plug back into x is going to make my solution be true. It's going to make my solution be correct. No, our answer is x equals negative 8. This is just checking that you did your math correctly, which is especially extremely true with our integer rules, right, guys? I'm not saying you have to write this out. You totally can. I'm not saying you have to, but at least double check your work. Okay, so let's go look at number 2. Same thing. You are going to put a line down your equal sign. You want to split up your two sides. I don't care where the equal sign is at. The line always goes on that equal to sign. And then I have m minus 11. I want m to be all by itself. How do I get m all by itself? I'm going to add 11 because I am going to do the inverse of what I see. I see a minus 11. The inverse of that is to add 11 because negative 11 plus 11 is 0. So those 11s cancel out. They go away. I'm left with m equals, and I have plus 11 on the other side because whatever I do to one side, I have to do to the other side. And negative 9 plus 11, integer rules, guys, is positive 2 or negative 2. So if you plug that 2 back in, it now says 2 minus 11 equals a negative 9. What's 2 minus 11? Does negative 9 equal negative 9? So we know we did it right. So our answer is m equals 2. Questions so far? Is that making a little bit more sense?
Yes, definitely.
You got to do the inverse operation of what you see. Inverse means opposite. You do the opposite operation of what you see on both sides of your line. So on number 3, if we draw a line on the equal sign, everyone draw that line on that equal sign. Now here's the tricky part. Remember how with writing expressions, combining like terms, those sorts of things, we always only looked what was in front of the number, right, guys? Same thing. You have to look in front of the number, not behind. So right here, if I have 14 plus h, the plus goes with the h, not with the 14. Okay, so what do I do to get rid of the 14? What will get my 14 to 0? A negative 14, a minus 14. Because 14 minus 14 is 0. Does that make sense, guys? And whatever I do to one side, I have to do to the... You have to do the same thing to both sides. Which is why I have you draw that line, because then you are seeing both sides. The 14s go away because 14 minus 14 is 0. You are left with h equals 9 minus 14. You have to remember your integer rules. What's 9 minus 14? Plug that negative 5 back in. Okay, it says 9 equals 14 plus a negative 5. Your integer rules, 14 plus a negative 5. What is that? Positive 9 or a negative 9? Why is it positive? And does 9 equal 9? Which is why h equals negative 5 or negative 5 equals h. You can write it either way, it's fine. Cooper. Yep, absolutely. Lelia. Because I want to get 14 away. The only way to get it away is to cancel it out, to get it to 0, to make it go away. Because if I have h plus 14, right? And I subtract 14 from that, what's that going to give you? It's going to give you 0, right? Well, h plus 0 is the same thing as just saying h. You don't need that plus 0 there. Does that make sense? You can't see that, sorry. Does that make sense? You're getting rid of that. So that's why we're doing the inverse operation, because it's whatever you see. If you do the inverse of that with the same number, you're always going to get it to 0, or it'll be different when we do multiplication and division tomorrow. But we're not going to do multiply and divide today, okay? Only add and subtract today. Luke. It's always the number on the side with the variable. Because you always want to get the variable by itself, and in order to get the variable by itself, it's always the number that is next to the variable. So when we look at number 4, this is why I say this is tricky, right, guys? So you got that line where your equal to sign is, correct, guys? Okay. Then, it's not blurry on you. Remember, you always look at the sign in front, right? Don't look at the sign behind. The plus goes with the W, the negative goes with the 15, right? I want to get rid of that negative 15. How do I get rid of the negative 15? Because negative 15 plus 15 is 0. I want those to go away. You're getting them to 0 every single time. And then I'm going to add 15 to my other side, because whatever you do to one side, you must do to the other. And 14 plus 15 is, so W equals 29. And if you plug that back in, it says negative 15 plus 29, which equals what? 14, which is why we know we did it correctly. You can always check your work with equations, guys. Always, always, always. The beauty of them. Yes. Yes. This is the method you have to use. So yes, you guys do have to learn this method. If you don't do this method on your homework, quizzes, things like that, you'll get a 0. You have to do this method. Is that understood? Because otherwise the rest of this unit's going to be really hard on you, okay? All right, 5. Draw your line over the equal sign. Split your two sides up. I want to isolate the variable, which means I want to get the variable all by itself. So what number am I talking about here? The 21 or the 8? The 8, because that's on the side with the variable. How do I get rid of the 8? I'm going to add 8 because I have a minus 8. I need to add 8 because a negative 8 plus 8 is 0. So those will go away. I'm left with K equals, and I'm adding 8 to both sides. Whatever you do to one side, you have to do to the other side. And then you just got to remember your integer rules. Negative 21 plus 8 is what? Negative 13. And like I said, you can flip that around and it can say K equals negative 13. That's technically proper, but I'm not going to worry about that, okay? Plug that back in. You have negative 21, and that equals negative 13 minus 8. Do your integer rules on negative 13 minus 8. What is that, everyone? Positive or negative? And negative 21 equals a negative 21, which is how we know we did it right. All right, last one in our notebook for today. Draw your line. I want to get the variable all by itself, meaning I want it to be v and equals. So what number do I need to get rid of? And what do I need to do to get rid of that negative 4? Because negative 4 plus 4 is? So those 4's go away, and whatever you do to one side, you have to do to the other. And don't forget your integer rules. Negative 1 plus 4 is? Plug that back in. You have negative 1 equals negative 4 plus 3. What's negative 4 plus 3, you guys? Does negative 1 equal negative 1? So we did it right, and that's our answer. Is that making a little bit more sense, guys?
Yeah.
Okay, let's get out our dry erase marker and let's do some problems on our tables.